All right, so example 2, a jet travels 3,950 miles from Chicago, Illinois to London, England, and the same amount on the return trip. The total flying time is 16.5 hours.
What?
Yeah.
That makes sense. Before. It does not take that long.
The total flying time.
Oh,
So there and back. But the return trip takes longer due to winds that generally blow from the west to the east. If the jet's average speed with no wind is 485 miles per hour, what is the average speed of the wind during the round trip flight? And then it says to round your answer to the nearest mile per hour, which is going to be the nearest whole number. Okay? 485. So what is the average speed of the wind during the round trip flight? Okay, so that is the question that we are trying to answer. Okay, so what is the average speed of the wind during the round trip flight? Okay, so it's of the wind, not of the plane. All right, so we're gonna list out the important information. So some of the things that we wrote down up here. So the distance is gonna be important. Really, this is gonna be the type of problem that uses which popular equation that we've already used this year? Well, what's the distance formula that you're referring to? Did we do a formula that has distance in it? We just, yeah, distance equals the, yep, distance equals the rate times the time. Okay, so if the distance is 3,950 each way, the total distance is going to be what? Okay, so to do this quickly in your head, probably be easier to add 4,000 and 4,000, right? Which is 8,000. But if I'm 50 short each way, I'm 100 short, so 8,000 minus 100 is 7,900 miles. All right, Paige, with something else that's going to be important besides the distance.
The speed.
Okay, and then what do we know about the speed?
It's going 485 miles an hour.
Okay, so the average speed, and this is without the wind, is 485 miles per hour. And Ashna, what's the last piece of information that's going to be helpful?
Total flight time.
Yep, and what's that?
16.5 hours.
Good. 16.5 hours. All right, so now we are going to make a plan. Okay, we're going to let W equal the speed of the wind. Okay, so if we're going to London, this is our distance D. We said it was 3950 there. We said it was 3950 back. Okay, the average speed, the rate when you're going to London this is when the wind is on your side. So it's going to be 485 miles per hour. That's, remember, with no wind. So we're going to have to add the speed of the wind to it. And then on the return flight, that would be the 485 minus the wind. Okay, so on the return trip, it's longer due to your winds. All right, now the last one for the time in hours. We know what the total is, but we don't know what each one was separately. So the total is the 16 and a half hours. Actually, maybe I should just make a box for the total, because we already talked about how this total here is 7,900, right? For this total, if I was finding the average, if you added them together and divided by 2, what would you get? If you add those two together, right? It's the positive wind minus the wind, those would cancel out. You'd have 485 plus 45 divided by 2, which would be what? Yeah, 45. All right, now we know that this one is longer than this. What we're going to use is this equation. So if I solve for t, the time is going to be equal to the distance divided by the rate, and that's how I'm going to find what goes in each box. Okay, so if I'm doing the distance divided by the rate, for this one, it would be 3950 divided by, our rate is 485 plus W. D divided by R. Okay, and again, because that's to London. Okay, this is our return trip. So for this one, I'm going to do D divided by R, so 3950 over 485 minus the wind. So I use the same thing for here. Okay, so this is your distance divided by your rate. This is your distance divided by your rate. All right, so what we're going to do is we are going to set up an equation, okay, for the time. Okay, so that's what we can use to solve for W. Okay, so to solve for W, okay, we're going to set up an equation with the time information. Okay, and the reason why we're going to do that, that's the only one with the unknowns where you're going to have the total such that you can solve for W. All right, so if we set this up, we're going to have the time, the 3950, 485 plus W. If we add that to the time of the return trip, we know that it should be a total of 16 and a half hours. And we can use our new strategy where we multiply each side by the LCD. right, so then our LCD for this one, I have 485 here plus W. That's going to be one of our factors. The other factor is going to be 485 minus W. The denominator here is 1, so I don't need to worry about that. Okay, so if I set this up, 3950 over 485 plus W. If I multiply that by 485 plus W times 485 minus W plus we can start canceling some things out. I'm just going to put the original equation in the same color so you guys can see what is happening here. Okay, so you have to multiply each part by the LCD, then you can cancel out the common factors. So the 485 plus W and the 45 plus W is going to cancel. So you'll have 3950 times 485 minus W here. Here the 45 minus W is going to cancel, so you're going to have 3950 times 485 plus W. And then here we're going to have to multiply those all out. Now, when you do multiply, you are going to FOIL. The first thing I would do is FOIL these two together. Okay, so when you multiply 485 times 485, you're going to get 235,225. And really, this is just the difference of two squares. So minus W squared. We're going to distribute here. And don't worry, this is one that you can do with your calculator. So will you get your calculators out, and I do want you to finish that. Okay, so once you do the distribution, what should happen on this side is the 3950W and the negative 3950W, those are going to cancel. Okay, and then this is just going to be double. So you have 3,831,500 equals 3,881,212.5 minus 16.5 W squared. Now, because you only have the W squared and you don't have the W, you can get all of the numbers to one side. Okay, so you're going to subtract the 3,881,212.5 from both sides. Just going to do that. Now, when you subtract, you should get a negative. Why would that be good in this case? Yep, the coefficient on the other side is -2, negative also. And so when you divide by the negative 16.5, that is going to make a positive number. And then to solve, you're going to have to do what? If you have W squared, you're going to take the square root. Now, really, with the square root, you do get the plus and the minus. Why are we going to be able to reject one of those? Yeah, you won't have a negative speed. Are any of you in physics yet?
No.
I don't think so. You won't have a negative speed, but you can have negative acceleration. So the speed of the wind is going to be approximately 55 miles per hour. Yay! Okay, and then the step 4 that says look back, that's when you ask yourself, does your answer make sense in terms of the problem? Okay, for instance, if you get something that was over the speed of the airplane, over 485, okay, that just is not realistic. So that is something that you do want to take into account. Could I also plug this in and then see if it fits with my average speed and time to see if that would give me a total of 16.5 hours? Could you figure out what each way would be? How many hours each one would be? What's the real question?
So like, the real question, well, why are you measuring it like that? Because like, if you're doing the actual flight, you're gonna have to add on like 5 hours, or like at least like 6, counting like customs on both sides.
That.
International customs.
Well, I think that it's just like the gate to gate. So when you plug back in the 55, you can see it'd be the 7.31, that would be the time in hours, and then the 3950. You know, sometimes if you, and then this one would be the 9.2 hours. You know, sometimes if you're taking a trip, like I would go to Florida, and like you'll arrive like 20 minutes earlier due to the winds. The winds are either working with you, helping it go faster, or working against you. So that does seem reasonable. And if you added those two together, you should get 16.5, 7.3, 9.2. All right, in our next story problem, there are going to be a similar setup, but just some smaller numbers that you're working with. So for this one, it says Natalie can finish a 500-piece puzzle in about 8 hours. when Natalie and Renzo work together, they can finish a puzzle in about 4.5 hours. About how long is it gonna take Renzo to finish a 500-piece puzzle if he works by himself? So really, what we're trying to find is his rate. Okay, so the question to answer is what we highlighted above.
It takes her 8 hours to finish.
Yeah, could be really difficult.
Straight work time? Like, no break. Dang, she's really bad at this.
We don't know how old Natalie is. We don't judge her puzzle skills. Okay, so think of this as a rate, okay? So Natalie can finish one puzzle in 8 hours. Okay, Renzo, we don't know his rate. So he can do one puzzle in, we'll just call this H. So we don't know how many hours. Bless you. Okay, so we don't know how many. But together, they can do one puzzle in 4.5 hours. Okay, so what we can do is we can set up an equation for the one puzzle, okay? So, at Natalie's rate, the 1/8 times the, sorry. Before I set this up, I just am gonna go over with you how you're gonna set this up. So what we're gonna do is we're gonna do the rate of Natalie. I'm gonna put nat rate, okay, times the hours together plus the Renzo rate times the hours together equals the one complete job, which in this case is a puzzle. Other times that might be painting a house or something of that nature. Okay, so then the rate of Renzo is 1/h times the hours together, and that would be one complete job.
We should make this a scientific experiment instead of like 3
So remember that the distance equals the rate times time, so that's what we're doing. Okay, this is the rate times the time. This is the rate times the time. Okay, so then if we multiply, we have 4.5 over 8 plus 4.5 over h equals 1. And then once you have this equation, all you have to do to solve is what? Get your LCD. Okay, so we're going to multiply both sides by the LCD, which would be 8h. Okay, and then so if you're going to do that, you would have 8h times 4.5 over 8 plus 8h times 4.5 over h equals 1 times 8h. Don't forget to multiply it on the other side. The 8's are going to cancel. And then here, when you're multiplying, 8 times 4 is 32. 32 plus 4 is going to be 36. And then you're going to get all of your h's to one side. Divide both sides by 3.5. And your H is going to be about 10.3 hours. If you wanted to figure out how many minutes, what could you do? Multiply what by what? Okay, so you can multiply 0.3 hours by 60, which would be what? What's 6 times 3? Right, times 60, so 3 times 6 is 18. So 10.3 hours, or 10 hours and 18 minutes is going to be his rate. Okay, so if you do the 0.3 times 60 minutes, your homework is online, but I am not going to check that tomorrow because we're going to finish 5-5 tomorrow. Okay, but you will want to start that.
Why does it say plans for tomorrow?
Because I am taking a half day to work on some stuff with the other Algebra 2 teachers, and I thought maybe that it would be missing this class, but I think it'll be the afternoon.